So I know you're not excited about this, but I certainly am, because I feel like I've been stuck in Module 1 with Algebra forever. It is September 8th when I'm making this video, and I'm finally in Module 2. Now, let me explain why I'm so excited and why I'm so far behind. So I teach 2 classes, right? I teach pre-algebra, I teach algebra. I've already taught you 6 lessons of the prep module. Then I taught you about 20-ish lessons in the Module 1. So that's 26 lessons, right? Plus I've had to make videos for your review packets. So let's call it 30 videos, okay? Give or take. Well, that's great, except I also have another class. So again, these videos last anywhere from 6 to 15, 20 minutes. You do the math on just algebra. And again, it's September 8th. Is it? Yeah, it's September 8th. And you might be saying, Mr. H, how do I know it's September 8th? Well, if you look over here, I've still got your first quiz stuff up. So that tells you that it's still early in the year. But anyway, but then I also have pre-algebra. And the pre-algebra videos are the same. And I've made all of Module 1, which was 10 videos. And we've made all of Module 2, which was another 22 videos. So again, put it in about another 35 videos. So I've made somewhere in the ballpark of 65 videos. And again, do the math. Let's say it's only about 8 minutes an average, which isn't true. It's about 10. If I've made 60-ish, 65 videos at 8-minute average, do that math, and then you'll realize why I'm so frustrated and so happy to finally be in Module 2, because it takes a lot of time. But anyway, I digress. I'll be done complaining. Lesson 1 of Module 2. Module 2 is all about statistics. Now, where do we see statistics? Well, we see statistics in a lot of places. We see it in sports, batting average, greens in regulation if we're golfing. But more importantly, and my wife and I were both big into this summer, were the statistics from COVID. Because there was a lot of false information out there as far as what the statistics counted as. Statisticians are brilliant in the fact that they can use numbers to paint a picture that they want you to believe. The key about statistics is interpreting the data the correct way. And it's all about data. Statistics is all about data. There is a story behind all of statistics. Because, yeah, you know what? You guys are probably too young, but ask your parents about Ichiro Suzuki. Ichiro Suzuki was one of the best hitters in the early 2000s, late 90s. Okay? He came over from Japan, and he was one of the Major League Baseball's best hitters. Why? Because he could hit singles, outrun them in the infield, pop it out to the outfield, and still outrun it. And he had more singles and doubles than any other player in the league. And he broke 3,000 hits in the Major League Baseball. Plus, he had over, I think, 1,500 hits in the Japanese league. He was one of the best hitters ever. But the statistics don't tell you what those, if he had a 345 batting average. Well, that doesn't tell you how many home runs he hit. It doesn't tell you how many runs he batted in. It doesn't tell you how many runs that he actually scored. Just because he's getting on base, that doesn't necessarily mean that he's doing his team any favors. So statistics can paint a great picture. I can make Ichiro look like the best hitter ever, and I can make Ichiro look pretty darn average by comparing player A to player B and saying player A scored 350 runs over these last 5 years. Player B, again, statistics can be adapted to tell a story that you want them to tell. So you just need to be careful about statistics. Several different ways that we're going to look at them right now. All ways that you've learned are graphs. So this is a dot plot and a graph, okay? So you've learned dot plots probably for years now. We've got a dot at 7, 8, 9, a bunch at 10. So what's happening is this looks like if this was a balance, it would be very heavy on this side. There's a lot more dots on the greater side of 40 than there is on the less side of 40, okay? So this data is skewed this direction. So whatever's watching this show is not necessarily for you guys. It's more for, it's not even necessarily for me. There's barely any people in my age range that are watching it. It's all these people who are slightly older, slightly younger. Like, it's these people. So this story could be told a lot of different ways. We could say this show is for the very young and for the very old. Well, is that true? Well, not really, but we could make it tell that story. But again, it's skewed to one side. It's not balanced. Well, what else do we know? A histogram is really like a bar graph that's touching. This is also skewed. Well, which side is it skewed to? It's skewed to this side. Why? Because it's a lot more densely populated over here, and then it tails off. Skewed to one side and tails off to the other side. So we could say, hey, most of the ages are between 20 and 0. That's the biggest percent, okay? Not a lot over here between 60 and 90, but you still have some. Again, the data is skewed. It is not balanced out. And when we talk about data that is skewed, we're going to be messing with some funky things here because we want to have our data balanced. And box plots. This is one of my favorite because when I was in Virginia teaching, I used standard deviation and box plots a lot to see whether my really high honor students were actually that high. Because each of these talks about 25% of the students in a class. And the 25% that are over here have more pets than the 25% here that has more. But what I did was I found out who really was my highest students by having, so here was average. Well, just because you're on this side of average doesn't mean anything. But if you're way out here and you're an outlier, that's an important thing. And the things that we use in statistics are several different things, mostly mean and median. Mean is the average. The average, we take all of the scores, we add them up, and then we divide it by the number of things. So let's say we're doing test scores. You take all of your tests, you add them up. So let's say you had 3 tests, you got 90s on all of them. So you have 270 points. And then you divide it by 3. That gives you the average for the test, which is a 90. Let's say you had 22 tests. Okay? Anyway, you divide it by 22, that's the mean. The median is the middle. It's just like when you're driving that concrete path between a highway, it's the median, it's the middle. So if I have 5 scores, 20, 30, 40, 50, 20, 30, 40, 50, 60. I'd go 20 and 60, 30, 50. The median is 40. Is that going to be my average? Well, sometimes the median is the average. Sometimes the median is not the average. Okay? More often than not, the more accurate one that we want to use is called the mean, and we'll talk a little bit more about that. But a box plot has 4 quartiles. 25% in the first quartile, 25% in the second, 25% in the third, 25 in the fourth. The range of a box and whisker is from this high end, taking it away from the low end. So that's me teaching it today. You actually are going to have homework. We're going to go over this quickly in our groups tomorrow because are there better answers than not? Yes. Are there perfect answers? No. So when I put you into groups tomorrow, I'm going to want you to argue productively whose answers are right. So you're starting off here at this exercise with the dot plot. You're doing questions 1 all the way through, I think, 13, if I did this correctly. 10, 11, 12, 13. Oh, 14. I was off. 15. Yep. So you're doing 1 through 15. One more time. You're going to do those. You're going to come in. We're going to discuss them as a class. Again, there is no perfect answer. You just need to look at it and tell the story that you want to tell. Statistics are all about the data. Good luck. Beep, 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 beep.